Hey guys, welcome back to my channel. So today we are going to discuss another problem. But before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is minimum operations to reduce x to 0. So in this problem, we are given an array and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array and subtract its value from x. Note that this modifies the array for future operations. Return the minimum number of operations to reduce x to exactly 0. If it is possible, otherwise return -1. So what the problem is, let's see. So here this array is given to us, right? Integer array is given and integer is given. So this array is 1 1 1 1 4 2 3 4 2 3 and target the x value which is given is 5. So basically what we need to do in this question is, right, we have to reduce this value of x to 0 if possible. And how we can reduce this value of x at one operation, right? One operation, we can either remove element from the rightmost end or element from the leftmost end of this array. So whichever element we will remove, right? For example, we are removing 3. So what we can do, we can subtract this 3 from this x value and we'll get what? 2. Okay, so this is what we can do. So now we have to, the output should be the minimum number of steps to reduce this x to 0. So minimum number of operations. In one operation, we can either remove from the rightmost end or from the leftmost end. So let's see how we can do it. So see, first of all, we have this x is equal to 5, right? So let's say I am removing from the rightmost end. So I'll remove this 3. So if I remove this 3 from this 5, what I'll get? If I remove this 3 from 5, so I will get 2, right? And this is one operation. Okay. And there might be a case that if I remove this 1, so if I remove 1 from 5, so what I'll get? 4, and this will be one operation. Okay. For example, let's say this is I variable, like this I is pointing here and j is here. So initially this will be I comma j. So now if I subtract this 3 from x, meaning I am removing this 3 from this array, so this j will come here. So here what will be? I comma j minus 1, right? We can say j minus 1. Otherwise, if I remove this 1, then this 1 will be removed from the array, so I will come here. So this will become I plus 1 to j, right? Similarly, now this 2 also has two options. So either we can remove this from this 2 or we can remove this one, because it's from I to j minus 1, right? So either we can remove this 2 or we can remove this one. So if I remove this 2, so we will get 0. We'll get 0 and it will be I from I to j minus 2, right? J will come here. So we get 0, right? And this is another operation. So in how many operations we got 0? We got 0 in 2 operations. So this is the minimum number of operations, hence output will be 2. Okay, output will be 2. So this is one way, right? And I hope you are getting like why in this what concept we can use. So here see why I have created this tree, because for every a point of x, right? Every x, any point of time, we have two choices. We have two choices. Either we can remove the leftmost or we can remove the rightmost. So here what we can do is we can do recursion, right? We can do recursion. So this is one solution. But guys, this will not be an optimized solution, right? This is not optimized. So we have to think of something else. This is not optimized. Okay, let's do one thing. Let's see few more test cases so that you can better understand. So let's take this test case. 5, 6, 7, 8, 9. So we have 5, 6, 7, 8, 9 and x value is what? 4. So see guys, either we can remove 5 from this 4 or we can remove 9 from this 4. So if I remove 9 from this 4, we will get in negative. And even if I remove this 5 from 4, we will get negative again. So if we choose any, right, we are getting a negative value. So obviously negative value we cannot uh, make it to 0, right? Because we can only subtract from this, right? We can only subtract. We cannot add anything in it. Here only we can subtract the value. So we will never get 0, right? We will never, because this is only negative. How will get 0? So in this case, output will be -1. Output will be -1, right? Because there is no, it's not possible to reduce x to 0. Now let's see one more test case. So let's see here. It's 3 to 20, 3 to 20, 1, 1, 3, and x value is 10. Okay. So here what, let's see what we can do. So you can make the recursive tree, like you can subtract 3 from 10 first, or you can subtract this 3 from, like that you can make. But I will show you the solution. So basically what we will be doing in this case is, see, we have this 10, right? So from this 10 we will remove 3 first. You can choose either of 3, or this one, this 3 or this 3, doesn't matter. So then we will get 7, right? So from that 7 we will remove so we will, from that 7 we will remove 1. So what I am doing is, I am showing it like this. Just a second. Okay. So see. So let's say I am removing this 3. Okay. I am removing this 3. So this 3 is gone, right? Now the array is this. So now I can either subtract 3 or I can subtract 1. Let's say I am subtracting 1. So from this 7 I am subtracting this 1. So we will get 6. Now again let's say I am subtracting this 1 from this 6. So we get 5. Then let's say I am subtracting this 3 from this 5. So we get 2. And then we are subtracting this 2 from this 2. So we get 0. So x reaches to 0 in how many operations? This is one operation, this is one operation, 1, 1 and 1. So how many? 5 operations. 5 operations, right? And these will be the minimum number of operations only. So output will be here 5. Output here will be 5. Now see guys, from this test case, right, let's think of another approach, because the approach which we discussed right now, the recursive one, will be not be optimized, right? So see, what we need to do is we need to reduce this x value to 0, right? That is, we need to see, like, basically there should be some numbers. These are some numbers, right? These are some numbers which will be on the ends, right? Which will be on the ends, like this is on the end, then this is removed, then this will be on the end. So these are some numbers which, when combined together, right, or we do sum of them, we get x, right? See, 3 plus 2 plus 1 plus 1 plus 3. This is what? 10 only, right? 10 only. 3 plus 2 plus 1 plus 1 plus 3. We are getting 10. So this is what we wanted, right? We have to reduce x to 0, right? So if we subtract x value only from this x value, so then only we'll get 0, right? What about the rest of the sum of the elements? See, these elements which are in circle, these will get subtracted from this x value, right? But what about the rest of the elements in the array? So see, this 20 is the rest of the element. This 20, if these elements have some x, so what will be the sum of the rest of the elements in the array? Let's say we know total sum of the elements in the array. So if we subtract x from it, we will get the rest element sum, whatever the rest of the elements are, because these will be x, right? So whatever the rest of the elements are there, their sum we can get like this, rest element sum. So those rest elements, right, those rest elements will be a sub array. Those will be a sub array because those will be together only. Those will be together only because these what we are doing, we are removing from the ends, right? This got removed, this got removed, this got removed, then this got removed. Whatever the rest of the elements are, those will be together only, right? If you agree on this part, then you will be able to understand this approach. So what we will do, right, we will find a sub array. We will find a sub array of sum this sum of the rest elements. Once we got that sub array, right, we will find out its length. And since, if you remember, we want the minimum operations, right? Minimum number of operations we want. In the problem, we need to find the minimum number of operations. So minimum number of operations means we want these elements, the circle elements, to be less in amount, right? So if these are in less amount, meaning this subarray should have more elements. If rest of the elements are more, these x elements will be less, right? Obviously. So what we want, we will find a subarray of sum this, and that subarray should have the max length, so that these elements which sum up to x are in less amount. Then only we will be able to find out the minimum number of operations. So let's discuss once more again. If you are not able to understand, don't worry. Let's discuss again. So what we will do, right? We have a array, right? We have this array. So let's say this one, and this one. These are needed for x. First we remove this one, then we remove this one, and then we remove this one. So these three elements are needed to make x to 0. Okay, for example, let's say x is 5 and this is what, 3 1 1, and these rest of the 7 6 2 1 3 5, like this. So what we want is, in order to reduce this 5, we want this element. First we'll subtract 1, then we get 4, then we'll subtract this 3, so then we get 1, and then we will subtract this 1, so then we'll get 0, right? So we need these 3. Now if we do not consider these 3, the rest of the elements which are left will be a sub array, right? Like, see, this is a sub array, and the sum of this sub array will be what? Sum will be total sum of this array, whatever the total sum is, minus the sum x. Why? Because these 1 plus 3 plus 1 is what? X only, right? So x. So this will be the sum. This will be the sum of this sub array. So this will be, let's say, total sum is 3 plus 1 4, 4 plus 7 11, 11 is 17, 19, 20, 25 and 26. So 26 minus 5. So this will be 21. So we need to find a sub array of sum 21. So sub array of sum 21, right? Sub array of sum 21, and this, if this length is more, right, sub array length will be more, so these elements obviously will be less than, right? Because we need to find minimum operations, minimum number of operations. So if you have to find minimum number of operations, meaning we need to have these less numbers, like these numbers should be less. So if these numbers are less, the cross ones, then these will be more. So we need to find sub array of sum 21 having max length. Alright, so this is what the requirement of this problem is. So this problem is now reduced to a sliding window problem. Sliding window, because when we have to find a sub array, see, what is the identification of a sliding window problem? We need to find a sub array of a particular sum, having some constraint on the length or right, having some constraint. So this is clearly a sliding window problem. All right. So now let's see how we can find out this subarray. Once we found the subarray, right? Let's say we have found the subarray. We have to find its length. So 1, 2, 3, 4, 5, 6. This is subarray has length 6. So how many number of operations will be needed? The total length of the array, which is 9, minus this 6. So 3. 3 will be the number of operations. 1, 2 and 3. Okay, this is the benefit of finding the length of the subarray. So length of the subarray, total length minus length of the subarray. This will give you the minimum number of operations. Okay. So I hope you understood the approach. Now let's dry run this approach. I will be taking, let's say, this test case. So you also dry run along with me. So 3, 2, 20, 1, 1, 3, 1, 1, 3, and this is x is equal to 10. See, what we will do, first of all, we have to find the subarray, right? So we will take two variables. First of all, this is we have to maintain a window, right? So we will take two variables, I and j. I will be the start index of the window, and j will be the end index of the window. A sum variable we will take, which will tell us what is the current sum of the window. This is window sum. So it's initially 0. And how much sum we need to find of the window? That will be the total sum minus x. So total sum is what? 5, 25, 26, 27, and this is 30, right? 30 minus 10. So 20 subarray sum we need to find. This one. Okay. So let's find out. And we will also take a max length variable, which will store the max length of the subarray. Because this is what we need, right? So let's start. So I initially here. So let's start this. So initially I will be here at starting index. So let me do indexing also 0, 1, 2, 3, and j also will be here. So we will move j, we will add this 3 in the sum. This sum is the current sum of the window, right? Current window sum. Okay. So see, we go j will go here. Then j will become what? This will be 3 plus 2, 5. So this window currently has sum 5. Now j will go again forward. So 5 plus 20 will be what? 25. Now see guys, now this window from this to this has sum 25. Now we want the sum, the target sum. Let's say this is target. So the target sum which we want is 20 of the subarray. But right now our subarray sum is getting to be 25, which is greater than 20, right? Which is the target. So we have to reduce our window. So for that, what we will do? We will shrink our window. So how we will shrink it? We will reduce this I. Now this I will come here. So this 3 will get eliminated from our window. So we will subtract this 3 from the sum. 3. So this will be 21. I will come here. This is start of the window. So a window is now 220. Now this is our window. So this is not the window. Now this is the window. Now this 21 is again greater than 20. So what we will do? We will again move I forward. And this 2 will get subtracted. Okay. And this will become what? This will be 22. 25 minus 3 will be 22. And this 2 will be subtracted. So this will become 20. So now 20 is what the desired sum is, right? Target. So meaning we found the subarray. We found one subarray which has sum 20. So we will find out its length. So how length we will find out? J minus I plus 1. This is how we find out length. Why we are adding 1? Because these are indexes, right? So j is what? 2 minus I is what? 2 again plus 1. So this will be what? 1. So max length we will update to be 1. Now again we will move forward j. So j will be, sum is right now 20, so it will become 21. Again it becomes greater than 20. So we will shift our I and we will subtract this 20. So 21 minus 20 will become 1. So now right now this is our window, only 1. So j will go ahead. 1 plus 1 will become 2. Then j will go ahead. This 2 is less than 20, right? So we are moving forward. 2 plus 3 will become 5. And we go j. So we have traversed this. Whenever j reaches at the end, we have traversed the array. So we'll stop. And we found only one sub array which has sum 20. And its length is 1. Now this sub array has length 1. So total length is what? 6 minus this sub array length. So 5 are the number of operations which we need to reduce x to 0. How 5? See, this one we need. So 1 operation, 10 minus 3 will be 7. This is one operation. Then 10 minus 1, 7 minus 1 will be what? 6. This is one operation. Then 6 minus 1 will be 5, and this is one operation again. Then 2, then what we will minus 3, because we have to remove from the end, right? So 5 minus 3 will be 2. This is one operation, and from this 2 we will remove this minus 2. So this will be what? 0. So this is one another operation. So how many? 1, 2, 3, 4, 5. That is 5 operations. Okay. So output will be 5. So I hope you understood the problem and the dry run. Time complexity, we are doing a single traversal, so it will be O of n. And space is constant, we are not using any extra space. Let's see the code once. Try to write code by yourself. So see, what we are doing is, we have taken this sum variable and we have taken this size of the array. First of all, we will calculating the sum of the total sum of this vector. And then we find the target, which is sum minus x. That was this 20, right? Then we will be having this current sum variable, max length, and I. This is starting index of the window. Starting index of subarray, you can say. And this is like a variable to find to check whether we found the subarray or not. Because if we did not find it, the answer will be minus 1. Then we will start traversing. We will add in the current sum. If that sum becomes greater than the target, we will start removing, shrinking our window. So here we are shrinking our window. Otherwise, if the sum becomes equal to target, we will set found to true and we find out the length. If at the end found is true, we will return n minus max length, because those are the number of operations. Otherwise, we'll return minus 1. So I hope you understood the problem and the approach. If you found the video helpful, please like it. Subscribe to my channel. Let me know in the comments if you have any doubts. Thanks for watching.